In this video, we will be completing numbers 40 and 42, and the directions for this set say, state the degree, list the zeros, state the multiplicity of each zero, and whether the graph crosses the x-axis or does not cross the x-axis. And my phrasing for that in your study guide is that when the multiplicity is even, the function bounces, and when it is odd, the function cuts at that zero. So we're going to go in order here, list our zeros. And it did say list the degree. Well, this is because if I distributed that negative x cubed, I would have negative x to the fourth minus, plus 2x cubed. And now, if you've remembered what we did earlier in this chapter, possibly even in this lesson, you looked at where, when you have a function that's made up of monomials like this, the weak one wins in the middle, and the strong ones win on the end. So keep that in mind as we go through. The degree of this is 4. And so we have a leading coefficient that's negative, so we know that the overall shape at the ends is going to point down. So we're going to head to negative infinity for our y's in both directions. Our zeros, we look back at the initial factored form and record the values that make each factor 0. So we would get 0 from negative x cubed and 2 from x minus 2. And just to make this a little easier to draw, since our zeros are so close together, I'm going to go ahead and plot 0 at 0, but let's go ahead and make this graph go that 2 boxes is 1 in each direction. And then for our y coordinates, we'll go by the same thing. So, just trying to think ahead to where we're going. So we're going to spread this graph out a little bit. So we have a 0 already plotted at the origin, and we're going to plot our second 0 at 2, which would be here. That looks really dark on that graph. Let me get a better color that's going to show up. Okay, so we're going to plot the origin and 2 as our two zeros. Well, then we were told to determine the multiplicity of those zeros, and the multiplicity, in fact, let me rewrite this so that we can do it this way. Alright, we're going to put a comma behind that, but now we'll put the 2 underneath here. And the multiplicity of 0, because the exponent on its factor, x cubed, was 3, which of course is odd. It's an odd number, not functions, don't panic. It's an odd, which if it's odd, what that tells us is that the graph should cut there. And then for 2, our exponent was 1, because no exponent is 1 as our multiplicity, which is also odd. So this one, the graph should also cut at this 0 as well. Make my imply 0. The graph cuts at both locations. Well, if I'm working on this graph and I'm thinking, all right, I know because it's a quartic function or fourth degree function that it points down at the ends, then it's pretty hard for me to go wrong. And if I can get the rest of the picture to make sense in that way, I'm in great shape. But I'm going to bet that there's only 1 or 2 people out of every 20 or 30 that would think to do this. But since we've written the function as negative x to the fourth plus 2x cubed, I know that in the middle it's going to act cubic, which a cubic graph would come down like this to go in that direction to the left. But it's going to kind of wiggle back up this way, close to the y-axis. But then I know that the graph has to go up to come back down and cut through here and wind up out there. And that's roughly what the graph should look like. Now let me tell you what I will not hold you accountable for. When you're drawing this function from this information and you are sketching it out as you should be doing this with no calculator, you won't really have a way to know what's happening at this little peak that you draw when you curve the graph up, but I will not take off for that. But let's say I gave you this problem to do on a test and ask you for the range. Your range should match the way you drew that peak. All right? Now, to prove to you that this works and to show you the power of what you're learning here, let's look at how this actually looks from its graph in the calculator. And there it is. Now, this is a really zoomed in version, which would change the proportions somewhat, but it doesn't have to be perfect. It just has to have the behavior that we're studying in the right spots on the graph. Same set of directions on number 42. And our degree, the way we determine that is to think, all right, well, I have a linear power or factor of x minus 1 to the third power. So that means I have 3 powers of x from the first term, or the first factor. And then I have 2 more powers of x multiplying that. So really, you can just remember you can add the exponents together to get your degree, which would be a 5th degree. And then our zeros, remember those are just the x values that make each of the factors we have 0. And what would make x minus 1 0 is 1. And what would make x plus 2 0 is negative 2. And so we're going to kind of do this almost like a little mini table here. The multiplicity of the 0, 1 is 3, which is odd, which tells us the graph will be cut, or we'll cut the x-axis there. And then for our multiplicity for negative 2, we have 2, which means that our graph should bounce at negative 2. Now, the thing we haven't mentioned so far is that our a, which really matters, is 7. Because it's positive means that this graph will act like its parent, and since this is a 5th degree, it's going to look a lot like a cubic, so it should do something like this. So in other words, to the left it should be pointing into negative infinity direction. To the far right of the graph, it should be pointing in the positive infinity direction. So we're going to keep all that in mind and sketch the graph. So we start by putting our zeros on the graph. And our first one, working from left to right, would be at negative 2. But again, I'm going to change the scale of this graph, but this one I'm going to change different ways, and I'll explain that as we go. We're going to go by 2 boxes for 1, so really our scale would be 0.5 on this graph. So go ahead and add that to your picture. So this is 1 here. So let's go ahead and plot those zeros before we talk about the y scale. And our zeros are at 1 and negative 2. So I'm going to switch back to my orange color here to make it show up better. So I have a 0 at 1. And I have a 0 at negative 2. Okay, and I know that at negative 2 by my multiplicity, the graph should bounce. So it'll either bounce from below or bounce from above, and we'll get to that in a second as well. And it's going to cut at 1. Well, to help us get the overall shape, we'll remember that our A is positive, so the overall shape is going to act the same. So I know out at this side, and I want to show you, on the last one I kind of got lucky, but when you draw the arrows, you can go all the way to the edge and put a little up arrow and a little down arrow in the opposite corner, even though you probably won't go all the way out to the end. So you won't necessarily, those arrows won't actually necessarily be part of your graph like they worked out to be on number 40. And that was literally just luck. That was not like, that's how skilled I am or anything. So now I'm going to combine that with the fact that, so now I know that this graph has to bounce from this side because of the even multiplicity at negative 2, and it has to cut through over here because of the odd multiplicity for 1. And so then, to get it a little more precise, because there's a lot that could happen between our two zeros, it's always helpful if you also plot your y-intercepts. And to get your y-intercept, you just need to know what f of 0 is. And for this problem, f of 0 would be 7 times negative 1, because negative 1 to the third would still be negative 1, times 2 squared, which would be 4. So it would happen at negative 28. So this is where, and you probably thought I had forgotten by now, but I actually didn't. This is why we're going to go by 4s on the y-axis. So this is going to be positive, and just all you have to do to show that is put a positive 4 at the first mark. So when we plot 7 times negative 1 times 4, that would be negative 28. So we're going to go down 7 boxes, and that way we can actually get it in our picture. So 1, 2, 3, 4, 5, 6, 7 puts me here. So I know this line has to come down through here, and it's probably going to do some sort of sweeping thing, and that was too big of a hook, so let's fix that. So now it's got to come up, bounce off of that, because it has to do all this with a smooth curve. And you're not going to have any like huge hiccups or anything as you go if you don't know something more about the graph. So then you just make that come on down. And then to kind of clean up your picture, since we had put that arrow sort of in the way, you can come back and take that arrow back off if it looks like it's trying to be part of the graph when it's really not meant to be. And then we're going to come up and take care of this other side over here, and we're going to draw it out where it cuts through at 1 and then goes up to the edge of my graph. And again, that's how you know that I want things done to the edge of the graph if you've watched all my videos. And then, again, I've graphed it for you to show you. And it doesn't have to be perfect, as I said. What I'm looking for when I look at your sketches is that I can tell that you have a nice, smooth shape overall because it's a polynomial, and it does what it's supposed to do at each of these key points. And here's a picture of the actual graph where we've got a little bit going on here that would have been hard to predict, and it's right in this area. Everywhere else, if you look at this, it's pretty close to what you have sketched on your paper. This little spot, at this juncture, I would not expect you to know too much about that, but what we drew would be a perfectly fine graph for a sketch. And that's the end of this video.